architecture is a different thing. I am talking about physical space. So my name is Cry, and I work in architecture. You may be wondering why I'm at a tech conference then. Well, basically, I'm a designer by day, a photographer by night, and a geek always. And by that I mean I spend a lot more time paying attention to these sort of companies than I do typically my own industry. But besides my personal interests, within the firms that I work with, I look at ways of leveraging technology to further design, both in how we create it and the designs that we're actually creating. Now, the firm that I work for is Gensler, and it's the sort of firm that, well, a few tech companies know us. We do large architecture projects, such as Shanghai Tower. We also do retail, but a lot of tech companies will know us for our offices that we design for them. And we do a whole range of other sort of levels of design. And I could go on about our company, but I'm not going to. What I want to talk about is, I want to show you behind the curtain. I want to show you what we do and how we do it. Now, in order to understand the technology that we're presently working with and the big steps that it's making, I wanted to take a look at the timeline of what got us here. So, if we kind of take a look back, what you're going to see is in sort of the 70s and 60s beforehand, we were doing everything manual, hand drafting, graphics came along, and the typical blueprint came along, which was great, sped things up. Then the big step, as you can imagine, computers came along. Drafting. This was a huge step for our industry. We moved from drafting physical drawings to actually getting into using computers. Of course, computing power increased. We started doing 3D visualizations. And as technology progressed, we tweaked these tools and refined them into sort of architectural or different disciplines. But more recently, there's been a bigger step. And some examples of that are building information modeling, parametric design. These are kind of what I call 3.0. And the reason that I see these as a big step, and our industry is seeing them as a big step, is because, well, 1.0, everything was done manual and by hand. 2.0, the computers revolutionized everything. But 3.0 is different. 3.0 is taking a look at, well, information, intelligence, analysis, connectivity, and there's a whole bunch of different technologies that are influencing this. But it's basically taking what normally would have been just sort of a very manual process of design and layering in smart information. To demonstrate this further, I'm going to take a look at two examples specifically. The first two I mentioned. So when you look at BIM, or Building Information Modeling, this is one that, well, there's a big question of exactly what is it, because it's revolutionary in our industry. In fact, the government is actually shifting entirely to BIM projects by 2016 for all of their work. So it's having a big impact, but what is it? Well, there's a big piece of it. It's information. This is talking about architectural projects that are typically drawings, and we're talking about layering in information on top of that. So, as an example, when we look at parametric objects within a BIM program, what we would normally see as a floor plan, not that interesting, not that detailed, but we're actually layering information into that. So that partition that you see that's highlighted, I can actually click on it, and it suddenly contains all sorts of information behind the scenes. So I can put in how much it costs, what's the manufacturer, what's the URL to find more detail on it. This is on a drawing on someone's computer. And it's the fact that where we would typically look at drawings, so a flat two-dimensional representation, we're actually virtually constructing projects before they're built. It's a huge step for our industry. It's a big step. But there's a lot of benefits out of it. And the other thing about it is it's more than just software, and it's a generic term, so a lot of people kind of get confused about it. A lot of people, when they hear the term BIM, think of stuff such as these companies. But it's not just the programs that we're using. So to give you an example of what I mean by changing the way of the game of what we're doing, this is an interior design project. If you can imagine, an interior design project doesn't typically have an entire building constructed around it, but in this case we found it beneficial. Why? Well, that was because once we actually got into it, that single central model that had multiple people working on it actually had all sorts of information embedded within it. This is the key to BIM. So that central model, I can actually pull what typically we would do, drawings out of it. You can do schedules. You can do visualizations. We can do quantity takeoffs, which then can be applied to cost estimates. We can even send models to fabricators to get them to build stuff for our project based off of the actual 3D geometry that's within the programs. And of course, the environment is a huge issue these days. We have to become smarter with our designs. So the other thing that we do is we can also do energy analysis. And this includes interior projects, not just big architecture ones. But the big picture here is the fact that this is now all being pulled off of one central piece, a central model. So, how does this benefit us? Well, it encourages collaboration, whereas typically we would be doing everything as two-dimensional representations. We're actually working with other consultants that are also working on BIM. What that allows us to do is it allows us to actually construct 3D environments, and then they can actually construct 3D environments as well. So you can actually see the ductwork that's inside the ceiling. And we can find conflicts earlier on that otherwise, typically, we would end up finding out either on site or as drawings are laid out and trying to do comparisons. So you can imagine that this is a big advancement for us. It's also letting designers focus more on design because you can actually step into the space. I imagine that anyone looking at that section can actually realize what it's about, whereas when we typically look at a floor plan, it's a bit more hard to decipher. It's also changing the way we actually work, and then our work and our process and our flow of how the project actually unfolds, because of the fact that it asks questions earlier on. It actually asks us to design things earlier, but what that avoids is the cost of change later on in a project. But I think the big thing here for our industry is the fact that we've actually moved from drawings to databases, and we're having to deal with that. Now, the reason that I speak this to the tech community is the fact that we are also becoming overloaded with the amount of information that we're getting. So that's BIM, and BIM has a small cousin in parametric design. And this one probably gets a bit more interest from the general public because it's kind of whimsical. You can actually drive your architecture through math and equations, parameters. So, how do you design this way? Well, there's two options. You can either adapt your design. So for example, when we're constructing a building, we may do a solar analysis to try to find out what sort of heat gain that building gets. We then take that information, feed it into a computer program. The resulting output is actually generating a facade by the computer's actually generating the facade. We can do multiple iterations to find out different possibilities there. And then we can choose one of those options and actually construct it into the project. So we can get our architecture to actually respond to our environment. The other way is growing architecture. And on the big scale of things, for example, with the Shanghai Tower that was designed, in order to create a complex geometry of the facade, we actually inputted equations into a program called Grasshopper, which actually then would generate the facades for us. And when I say equations, there's a lot of them. That's actually a visual representation of the mathematical equations that went into constructing that tower. So if you can imagine, this is an example of how technology can aid our industry and the fact that it can actually generate things that are easy to navigate and understand. But where parametric design and BIM are great examples, they also leave us wanting more. They also leave us with unanswered questions. And I would almost go so far as to suggest that the relationship between the tech world and the architecture and design world is one that needs a bit more work, because of the fact that when we look at how the industry is right now, there's a lot of big players on both sides of it. Slow, steady along on their course, they're going places, but how agile and easy are they to move around and adapt to the new change that we're facing? Things like changing for our environment, and innovation that's coming about. How much is this brought on board? Well, there are companies out there that do innovate and do create new programs. A lot of the times they come out and they do get bought up by big, large corporations, which will then bring them on board where they continue along that steady path. So I challenge this, Do we want to stay on that slow and steady course? The other thing is, our industry is built on a legacy. It's built on a legacy of design tools that, well, since the 80s, haven't really changed much. And if you can imagine, it's quite difficult to say to somebody, you're going to go to school for design, learn how to design, and then come into the industry where you're going to have to learn how to control the appearance of your drawings by entering a binary code into a command line. To us as designers, this is ridiculous, yet it's the nature of our business. So I challenge that. So is there another possibility? Is there a possibility of looking at how do we make ourselves more agile? How do we make ourselves easier to adapt to our changes? Can we get a relationship that is much more like a speedboat? Can we ask the question, what would Google do if it was basically designing more than just SketchUp? How would it foster this relationship? I mean, I really do have to ask the question, why can I find out more stats about my bike ride or my child's sleep patterns than I can about the floor plan that I'm working on? To me, this seems confusing. It's a huge industry, and there's lots of opportunity for it. And what opportunities am I talking about? Well, what sort of disruption is there? Are we an industry poised for disruption? I'd suggest so. As 3 examples, every day we do floor plans like this. Every day we try to find the most efficient office layout so that when you move into your new office space, you know that you've got the most people in there that you can fit, and it's got all the services you need. Is it not just a geometric puzzle? A sort of parametric puzzle? Possibly. I don't know if anyone's ever looked at this. I've never heard of it. And I do say BIM is a great tool, but as I said, it still leaves questions unanswered. I can produce schedules that give me information on, for example, square footages and counts. Believe it or not, as usual and expected, I'm still pulling all that information back into Excel to graph it and to do any sort of cross-analysis. This sort of information should be more easily found, more easily computed. Or when we look at external information, we do workplace performance index surveys where we're looking at what makes your workplace efficient and how do we actually give you what you need. But this is still external information that, well, if we wanted to bring back into a program like BIM, well, the only way I really know how to do it is through accessing an SQL server. To be honest, I don't think most architects know what SQL is. And if you really want to throw out far ideas, we're creating these virtual projects, creating a virtual environment. What happens to all of them when they're done? Is there a way that we can actually build a central location that would actually benefit us all from all this? So I would leave the statement out there that there is a possibility for something here. So keep it in mind that, well, the result of a conversation between a design firm and a tech firm could result in 2 things. We already know it can result in a really cool office space that we can design, but I'd also challenge that it could create the next Architecture 3.0 tool. Leave you with that thought. Thank you.
Wonderful.